Hello, ladies and gentlemen. We are now about to start part 3, Basic Scripting. In this section, we're going to talk about how you can use scripts in Unity to add interactivity to your game. All of your gameplay, all of your input controls, and so forth are going to come from scripts, and we're going to walk through how you do that in this section. So we'll handle basic interactivity, we'll talk about input capture, so how you get some input controls from your gamepads and so forth, keyboards, as well as talking about commands and event systems. So how do you issue a command to an object from another object, or how do you pass messages between those two so that you don't have to keep references to objects around. So if you want to say, I'm casting a spell in this entire area, I want to just send a message out to the world, and the rest of the world reacts accordingly, as opposed to trying to go through and iterate through all of the individual objects in the scene and tell each one of them that they need to do something. Those are the topics that we're going to be covering in this section. This is possibly one of the most important sections for understanding Unity and building a game. So we're going to go through the basics, and let's go ahead and get started. So one of the first things you want to do when you're working with scripting, if you're not familiar with scripting at all from the Unity perspective, is to open the scripting documentation within the Unity manual. In that documentation that you downloaded, it is going to be in the scripting section. If for whatever reason you find yourself working on a different version of Unity for your project, you can go into the version disclosure here, and in the drop down select which version you are going to be working with. Now, of course, we are working with version 2019.3, so this scripting section is for us. If we needed something else, we would simply switch over to that version, and it would show us the specific API calls for that version. Scripting has changed a lot over the years with Unity, so if you are going to be using a different version, be sure you're using the right scripting manual for that version. Now, before we get started, one thing to note is that we're not going to be teaching C# in this particular section. That's way outside of our scope. The goal is really to walk through Unity scripting so that the average C# or other developer, C#'s not that difficult to pick up, can build Unity scripts effectively. So we're going to do a quick overview of scripting, create some scripts, and have them do some things. And then later on, as we start building our real game project, we'll talk about some advanced scripts that are going to be available to you that you can use. Now, in the past, Unity supported many different languages for scripting. They used to support JavaScript as well as a language called Boo, but they no longer support those officially. You may still find references to JavaScript-based scripts around because there are still some developers that are using older versions of Unity that are continuing to use JavaScript, but C# is what you're going to be using both in this section and most likely for all of your games going forward. Everything Unity's doing in the future is all based off of C#, so best to go ahead and get accustomed to that. Unity scripts can be built in any editor that supports C#. Unity used to have a tool called Monobehaviour, which was built into the platform. They have since started to use Visual Studio as their IDE. If you're on a Mac, there's a version of Visual Studio for you as well. There's also an excellent tool from JetBrains, the company that makes IntelliJ, called Writer. So if you're used to IntelliJ, ReSharper, those sorts of things, Writer is the best tool for you. If you're a Visual Studio person, just use Visual Studio. If you're an Xcode person, your best bet is to just use Visual Studio because it tends to be better integrated with the Unity environment and understanding all of the various IntelliSense components that are present within Unity. Another tool that you'll see used quite often or mentioned often is the lighter weight version of Visual Studio called Visual Studio Code. That is actually an excellent editor, but it doesn't have all of the same functionality that the Visual Studio that comes installed with Unity will have. So you can use it. You'll just need to add some additional plugins to it to make it work properly. Now, of course, the best way to really use Unity and scripts and so forth is to really just use them. So we're going to go ahead and dive right in. We've created a new scene here, and we're going to add some scripts to some game objects. One thing that's important to note when dealing with Unity is that scripting functionality belongs to game objects. Just because you create a script doesn't mean that you can invoke it. If it's not in a game object, it's not a part of the scene, and Unity, for all practical purposes, doesn't know that it exists. It will ignore it. Now, all the scripts that are created in Unity are monobehaviors, and they're going to look similar to this. So a monobehavior is a parent class for all things that relate to scripts in Unity. And whenever you create a new one, you will get this start and update functionality. Now, in order to create a new script of our own, it's really straightforward. You just go somewhere. I have a scripts folder and say right-click, create, new C# script. So once you create that, we can just call our script a foo script. You can double click on it to bring open whatever editor you were using, and so now you see the foo script is here, and it has the same template as the other script that we were looking at. By default, any script that you create is going to have a start and an update method. That's just a legacy thing. Unity used to always do that to make it easier for new developers to know what methods they should be messing around with. We'll talk a little bit about the lifecycle in a second, but the start method is kind of your constructor. It's the first thing that gets called for this particular script, and it's only ever called one time. And update is called once per frame. So this is kind of your game loop function. In Unity, you're not going to be building the game loop, which is kind of making sure that the game is running. When the game is running, when you press play, the game is running, and the player is going to be running an event cycle internally, and so it's going to be calling update on your scripts, or fixed update in the case of physics. We'll get to that a little bit later. Now, with your scripts, you need to understand what order things are going to be called. So we said that Unity has its own event mechanism internally where it's going to be calling your scripts. So how do you know what the life cycle of a script is? Well, inside of your scripting overview, if you click here and we go to the order of execution for event functions, you'll see this. Now, all of this information is in the documentation. The scripting overview is actually very good. It will tell you everything that you need to know about Unity and the scripting system. If you really want to understand it larger than the scope that we're going to cover here, definitely read the documentation. Documentation is very good. It's gotten substantially better over the years. So here we have the Monobehaviour Lifecycle. This will give you an idea of how Unity executes scripts, the order of events that it's going to be running. Now, we talked about two methods. I showed you two methods, one being start and the other being update, that take place during the event loop of Unity. But I'm going to kind of walk you through all of the event loops so you understand where things are taking place. So with a script, the first thing that happens is awake. Whenever you get an awake call, that means your script is being called during initialization, or I should say pre-initialization, for your game object. So your game object is now alive. Your script that's on that game object is being told to get ready to do some stuff. And here, if you have some object variables that you want to set up and get ready, here's a good place to do that. You can also do it in start, but awake is usually a good place because this is kind of like your constructor. The next common method that you're going to see is start. Now the start, much like awake, is only ever called once for a given script. Now start is invoked when all of the game objects in the game are ready, all of the scripts have been initialized, and the engine is ready for you to start doing things. So the big difference between awake and start, and people tend to get these confused, is that awake doesn't mean that the rest of the world is ready. It just means that you've woken up. Everybody else might be sleeping. Once start is called, that means the rest of the world is ready and you can go ahead and start your day knowing that everybody else is already up as well. The next section is basically the physics section. So after everyone is awake, all of your scripts are awake, your game objects are ready, the physics engine is going to start running. And so we have this, while we have update, we also have this fix update. Now, fixed update happens multiple times per frame. And fixed update is where you want to do things that are interacting with the physics system, because this is when the physics system is running. So if you're trying to perform some physics operation or adjust the angle of something based off of some physics feedback, fixed update is where you would do that. The next ones that you're going to see happening, that we'll see a lot of, are going to be in the on animator move when we start talking about animation, and some of these callbacks for the physics system. So this is important to note that the physics happens before the input happens. So there's always a move and then the user has the ability to do something. That's important because fixed update may happen more than once in a single frame. So there are ways to scale that, and we'll talk about that a little bit, so that you can work with time, delta time, so that you can, if you're trying to move something 1 meter in a frame, there is a way to see how many time slices you need to break that up into so that it doesn't move at a jerky rate. You can kind of quaternion slurp it so that it moves smoothly as the time is passing by. The next one that you're going to commonly see is the update method. So this is where your script is going to be called once per frame, typically. So anything that you want to do, input is typically gathered in update as opposed to fix update, because fix update happens so often there's no point in trying to gather input at that resolution. And you could end up slowing your game down if your input gathering takes a lot of time. But you have update here, which is you get your input and you basically handle your gameplay right here in update. So things that you might want to do, moving the player, moving the enemies, deciding that you want to open this door, so forth and so on, all of those things take place in update. After the update, if there are any coroutines that are saying, hey, you need to wait for something to finish, or you need to do this at the same amount of time, those all run, and note they're running right after update. And then after that is the internal animation update, which is where all of the animator moves are kind of happening again. So you have multiple places where animation feedback is happening. Afterwards, you have your scene rendering. So these are typically not ones that you're going to event on at all, but if you were going to, this is where you would handle that. Then if there are any UI components, this is typically only called in the editor. So the little widgets that you see in the editor, those are drawn afterwards. Note that Unity is using its own stuff, so the renderer inside of Unity is using the Unity engine. Then on GUI is called for updating custom controls and so forth. But for all practical purposes, this is kind of the end. That's your game loop. You can pause your application and so forth. Then you can have an application quit. So there is a quit call that you can make on the application object to tell your application to quit. In that case, you get an application quit method call, and you can do some things about that. On destroy is when all of your stuff is being destroyed by the system, and then your game is kind of over. So that basically describes the game loop. So internally, Unity is constantly doing all of these steps every time step within your game. And as I mentioned, a time step might not be a single frame. You may have many different things happening during a frame, certainly with respect to physics, but you may have many things happening per frame, and Unity governs all of that. So you don't have any place where you're going to be doing a for loop and trying to, make sure things are working within the game and so forth. Unity's handling all of that. It's all based off messaging and eventing, as all good things should be. So just trust the process, and implement the methods where you're supposed to, and everything will work out just fine for your gameplay. So that's kind of the life cycle of a script. So now let's dig into some scripts so we can see how they function and how we can interact with the world based on that. So we want to go back to Unity. We have our simple scripts here. So we're back in our scene. And what we want to do here is we want to go ahead and let's create some simple script, create a game object, and add those two things together. So we'll go ahead and say create an empty or create a 3D cube. As good as anything else. So we see our cube here. We see all of our various components. Our transform, the mesh renderer is here, the box collider. We'll talk about colliders a little bit later. But we don't have any scripts associated with it. And there are two ways that you can add a script. You can do it from here and add component. We have a foo script. If we wanted to add the foo script, we could simply type foo. It would show up here. The other way we can do that is we can take the script and simply drag it onto our game object, and now the foo script lives on that game object, and it is only at this point that Unity knows that it exists, and it will actually invoke that script. Prior to that, we had written a script, but it wasn't in our game world, so Unity will not send any events to it. If there are times when you have scripts that need to run, but you don't want them attached to a game object, for example, you can add them also to an empty game object. So that's what create empty is really good for. You can attach scripts to empty game objects as well. Now, a script doesn't have to be attached to just one object. You can have it attached to multiple objects. So we have our foo script. It is attached to our cube here. We can also take our foo script and attach it to our game object. And this is another way that you can add a script to something. So if we go to this random empty game object, we see that it also has the foo script attached to it as well. Now that we know how to attach scripts, let's talk about having those scripts do something. And the easiest way to do that is to talk about how we have scripts interact between objects. Because typically what you're going to want to do is have objects interacting with other objects. So let's go ahead and add another object in. We'll take out our empty game object. We don't really need that. But let's go ahead and create another object. 3D object will create a sphere. And we'll move our sphere over here so that we can see it. We'll select our camera. Make sure that we can see these things in the scene as well. Control-Shift-F. So that our camera is now looking at those objects. And what we want to do is have the foo script know something about or know about the existence of the sphere. And an easy way to do that, we can go into the foo script, is to add what we say is a slot. And the way you create slots in scripts is to declare a public variable of the type that you want to be aware of. So we can say we want to create a game object called other, which would be the other thing that we want to look at. Now, game object is a type. There are other sorts of types. If you were trying to hold on to a texture, you would do public texture 2D, if, for example, it was a 2D texture, or whatever you wanted to store. You would just create a public version or a public variable inside of your script, and you would be able to store that. So now we will go ahead and save, and we will return to Unity. The spinner here means that Unity is compiling our scripts, and it has now finished compiling that. So if we go back to our cube, we see here on our script that we have a variable called other, which is what we called our variable inside of the script, and it expects a game object. Now we can click on the selection here, and it will show us all of the assets in the scene which are valid to be added into that slot. And if there are any assets that are valid to be added into that slot, we can add those as well. Since we're really only working with stuff that's in the scene right now, we'll just say I want to use the sphere. We can select it here, and you see that over here it is showing up in our foo script. The other way that you can do that is you can select the sphere here and drag it over into that slot. If it's something that's down here in your project, you could simply select it and drag it over into that slot as well. Those are the mechanisms for universally doing things in Unity. You can drag things into a slot. You can click on this selection disclosure and you'll be able to select valid things for that particular slot. And if there are ways, or if there are tools that do similar, the tools would show up here and you would be able to do the same thing on side of that widget. So now our script knows about our sphere, so we want to make sure that we can do something with that. So next we will modify the sphere. Let's just change its color to something so that we can see that the sphere is actually being referenced by the foo script. And we're going to do that by basically selecting our script again, and we will add some things so that we reference the other object that's been passed to us. And let's just change this to red, and that is done. We reference the other, which is the other game object that we're using, and we'll say we want to get a component from that object. And get component is how you get the things that are in a game object. This is one of the more fundamental pieces of Unity that you're going to be using. So if, for example, you want to get the material that is being used to render that object, or you want to get its transform so that you can move it around, or you want to get its rigid body so you can modify its physics, all of those things require using the get component method of a game object so that you can get that piece of the game object and modify it. So in our case, we have a mesh renderer. This is a mesh. It has a mesh renderer, so we will just say we want to get the renderer. And once we get that renderer, we want to get the material that's associated with that renderer. So let's kind of hop back over here. Unity will complain that our script won't build. But we are getting the renderer, and we're getting the material that's associated with that renderer, and we're going to change it. So back into our foo script, we're going to say that that material, we're going to take its color and say that it equal to color.red. And all of this information is all in the scripting guide. There's a lot of things you can do with Unity, with scripts and so forth. And you're going to have to read through a lot of that stuff to figure out how to turn your game ideas into scripting code that does stuff. But now if we go back, we see that we have built, we see an error here, so we can take this opportunity to talk about errors. So here, we'll ignore these. This is a Windows thing. But this script right here is saying there's an error on this line, essentially. So we'll double click on that. It'll bring us to the line in question, and I simply forgot to use this as a method. So the other game object, we want to get the component, that is a method, and use its material color, and we set that to color red. So we can go ahead and save that. And our error is gone. And now we know that our script is ready to go. So let's go ahead and run that. And now the sphere is red. So remember, what we've done here is we have taken a script and we've added it to the cube, and that script is impacting the object that we passed in here. The other thing that you might want to do when you're referencing objects is going to be to find them in the world. And there are a few mechanisms for doing that in Unity. And the best way to find those is to go to the scripting guide and just look at game object. And game object has a few methods, so you can do a find. So if an object has a name, you can find it that way. It's very straightforward. You can find game objects that have a tag. So if you are tagging your objects, so here is a tag. I mean, our objects aren't tagged right now, but if you want to add a tag to it, you would find all of the objects that are tagged in that manner. You can find the first one that it finds, find with tag. Get the components get the components that are in that particular game object, etc. So what we're going to do here is we'll use the find method. So let's go ahead and create another type of object, and we'll just do a 3D object. We'll create a capsule. That's a good one. And we'll move that capsule over there. Now let's use cylinder. Cylinders are always better. So we'll go ahead and 3D object. We'll create a cylinder. And our cylinder doesn't have any scripts associated with it. And what we want to do now is we want to have a new script that will not have the object passed into it, but we'll go and find our object, and we'll just call this guy Waldo. We're going to go and find Waldo, and we will make Waldo a particular color. So to find Waldo, what we're going to do is we're going to use one of the Unity methods we mentioned before. We can go ahead and open that up in the scripting guide, GameObject.find, and you see an example here of GameObject.find as well. So this finds a game object by name and returns it. We have already created the object and called it Waldo, so that is its name. So we want to find that object by that name. And we can see an example here, GameObject.find will return that object. So let's go ahead and do that in our script. So we will put this in the same script as the other one. We have a game object called Waldo, and Waldo will be equal to game object dot find Waldo. Now when we find Waldo, we want to do similar to what we were doing before. We want to say, Waldo, I want to get your renderer component, and I want to set your color to blue. So we'll let that script go ahead and compile, and note that they only compile when you return to Unity. Just because you save them doesn't mean that Unity is building your scripts. It's only building them when you return to Unity. That's the first time that it's ever going to try that. So let's go ahead and run this and see what happens. Cool. So now we see that from our single script that we have on this box, we are setting this guy to red, and we are doing a GameObject.find for Waldo, and once we find Waldo, we are setting him to blue. The next area we want to cover for scripts is actual input. How do we get input so that we can move these boxes and cubes and spheres and so forth around? And Unity makes that part very easy. Since the beginning, Unity has had a fairly standard input class that allows you to get the axes of movement for your various objects. When we talk about an axis, we were saying if you're moving from left to right, that's one axis, and if you're moving up and down, that's another. And Unity maps that to some standard metaphors on the keyboard. So W and S would be up and down, A and D would be left and right. Those are just typically gameplay metaphors, and Unity maps those. So if we want to get those, the first thing that we have to do, of course, is we have to get those values. And that is done using the input get axis, and we ask it for the axis that we want. So we go in here and we say float. We want to get the horizontal axis, and that's going to be input get axis, and we will say that we want the horizontal, and we want to get the vertical as well, so we'll go and get the vertical axis. Now you may be a little confused as how does Unity know what these things are? If you ever want to know where Unity or how Unity has these mapped, or if you want to change them, the place you go for that is in File. Let our script build real quick. File, Build Settings, and this location has changed a little bit, so it may be in a different place than where you're used to. Click on Player Settings, and in the player settings, you can click on the input manager. In the input manager, here are the axes that are defined. You also get a note here that says that you can configure these through the new input system. The new input system is much better. It's a lot more configurable, but it's also a little bit more difficult to use, and that'll probably iron itself out as it comes out of beta. So for now, we're not going to use the new input system. We will stick with the older axis-based system because it works very well, it's very performant, and many games still use that. So when we take a look at the axis here, we can see that there is a horizontal axis, and if we were to change the name here, we would have to change it in our code as well. And I haven't pre-configured this was already baked into Unity. So from a button perspective, it already knows that if you're pressing on a gamepad that has a left or a right button, it's mapping that to this horizontal axis, as well as the A and the D keys, it's mapping that to that horizontal axis. And so it's mapped to a key or a mouse button as well. Vertical axis, it is mapped to the down and up buttons, or the S and the W keys for being up and down. So that's how we would get that information, and how it's configured to show up in our system. Similarly, if we wanted to also get information about button presses and so forth, that information is here as well. So the fire button, fire 1, is automatically mapped to the left control button. If you were to press that and look for that event, it would tell you that it is pressed. Fire 2 is mapped to the left alt, and if we go down to fire 3, it is mapped to the left shift. And it's also, there's some mouse button mappings as well, but these are the default mappings for the input manager. So when you're getting things from the input system, if you ask for fire 2 and ask if it's down, it will tell you it's down if you're either holding the left alt or you're pressing mouse button 1. So that's where the input manager is located. You're going to go into the project settings. It's in the build manager. And then from project settings, go to input manager, and you can see things here. If you want to change them, you can change them here. There are other mappings in here. So if you're dealing with mice, there's no button specific, so it's not going to be a left right slide type of thing, but you can get the direction that the mouse is moving. Jump, I believe, is mapped to the space bar, which it is here, and some of the other things as well. So now that we know where these things are, let's talk a little bit more about how we're going to map them in our code. So back in our code, we want to bring up the script that we've been messing around with, which is our foo script. And so we've been getting these axes. And so what we want to do is validate that if we're moving in a particular direction, that we are getting that information of left and right down. And I will go ahead and type that in real quick. So if the horizontal axis is less than 0, then we know that we must be moving in the left direction. So we would do a debug.log that we're moving left. Else, if the horizontal axis is greater than 0, then we must be moving right. And the axis value would be set to 0 if that particular axis is at rest. In this case, that would mean that the key isn't being pressed. Similarly, we'll go into the vertical axis, and we'll say that if that's less than 0, we want to do a debug.log, and that is going to mean that we're headed down. Go ahead and put these semicolons in place. Else, if we are greater than 0, then that means that we are moving up. Okay, so we'll pop back into Unity, And we'll let that script compile, and it has, looks like we're missing a semicolon somewhere. Oh, this is supposed to be an else if. And moving on, return back to Unity, and we're built. So now if we go ahead and run this, we'll press play, that same script is now handling our inputs. So notice that we'll get a whole lot of events pretty quick, because as the key is being pressed, even if it's slightly being pressed, those are all events that are going to be happening in your system. So at some point you're going to want to scale the output of this so that you're not flying away as soon as you press the keyboard. You're going to want to tamp this down a little bit. But that's how you would get WASD motion out of Unity from the input system. We can go ahead and check for buttons as well. So let's pop back over to our script and do that. So where we can go to look for some of these input functions is in the documentation, something I encourage you to always continuously look at if you get stuck. So let's pop up the documentation for Unity. We'll put in input because all of the input is in the input class. And so we can see here all of our other input methods. And the one that we want is whether or not a button is down. So if a button is down, we want to do something based on that. So we can basically copy this code if we want to. So we will say we want to do something if fire 1 is pressed. Let's go ahead and stop our game, bring up our script, which is our foo script. So if input get button down fire 1, then we can do a debug.log and just say that it is firing. We'll go ahead and save that, return back to Unity, let that compile, and we'll go ahead and run. And now if we were to press the appropriate button, which would be the left mouse button if you're dealing with the mouse, or the left control if you're dealing with the keyboard, you'll notice that firing is working. So now you see how you can get your input from the keyboard and manipulate things in game space. So the next thing that we want to do is kind of walk around in our scene using just the information that we have. Now we can accomplish moving basically using the arrow keys as we saw in our script. So what we need to do is we need to get to the transform of an object, because remember, our object's position is based on its transform. So if we can manipulate that transform, then we can change where it is in the world. Go ahead and put that back at 0. So if we do this in a script, what we can say is, back to our foo script, if we want that object to move left, and remember this is going to be left relative to the object's axes. So if we select this cube, that's going to be this axis right here that we're manipulating. So our x-axis is the one that's going in and out of the screen, and that's just because of the way that we're positioned and where the object is. Because it's all relative. If we were to change where the camera is, that could be moving left and right, etc., etc. So remember that your transforms are relative to the gizmo, these values right here. So going back to our foo script, we can say, okay, cool, we want to, when the player is pressing the left button, we want to move that object to the left. Now we can do that a couple of different ways. The easiest way is to say I want to get the transform, and this is a shortcut for getting the transform of the object that of the game object that this script is attached to. So since this script is attached to the cube, we are getting the transform of the cube, and we want to modify that position. And in order to modify that, we need to give it the vector that we want, the new vector that we want that position to be. So we'll say new vector, and we'll say we want to take your old position dot x, and we will add 0.1 f, and that f means that we're adding a float to that. And then we want to take your transform dot position dot y. We don't want to change that at all, and your transform dot position dot z, and not change that at all. One thing you may be tempted to do, if you're not really familiar with the way Unity works, is you may be tempted to do transform.position.x equals, and you can't do that because the x is not exposed to you so that you can change it. You can only really touch transform position and you give it a new vector, so that's why we've modeled it this way. Catch yourself if you make that mistake. I mean, the editor will let you know that you can't do that. But that's something that you want to make changes, you do a new vector and you pass that to the system. And I'll go ahead and make sure this is a vector 3. Because a vector 3 is a vector with an x, a y, and a z. You can have a vector 2, which would just have an x, a y in it, etc., etc. We're dealing with three-dimensional space, so we want this thing to move in all 3 dimensions, even though we're only adjusting one of them at the moment, the x value. So let's save that and go back to our scene, and we'll go ahead and press play. And now that we are in the game, let's go to the console, and we can press the up, and nothing happens there. The right, nothing is happening there. The down, nothing's happening there. The left, so now you see, in that brief moment that we had that pressed, the left caused that object to move 31 times of 0.1 in increment. So the value, and you can actually go to the scene view and check some of these things out. If you go in while the game is running, go into the scene view, you can still see things. You can actually even still manipulate the camera and so forth in scene view without interacting with the game at all. And actually you may want to drag that next to it so you can see them both at the same time. But you keep pressing that and it just keeps on trucking. So that's how you can manipulate that. Now remember, this is just grabbing things from the input system. That event is making it to our script. We are just in the game loop. Every time the game loop runs, we are grabbing whether or not the left button is pressed, in this case the A, and we are doing something with it. We can do the same thing for all the different axes as well. So if we want to have the object move entirely under our control, we can go into the script and say we want this to move to the right. So instead of moving in that direction, we want to subtract 1 from that direction. And if we want it to move down, we want to move along the z-axis. So z down is going to be plus 0.1 f. We can go ahead and take that off of this one right here, and do the same for the other axis as well, simply subtracting along the z-axis. So we can go ahead and save that, come back into Unity, and press play. And now we can move in the various directions just fine. Now we're moving way too fast because we're not tamping down the input at all. And every time that we have a frame, that's happening. So one of the things that we're going to want to do is to normalize that so that depending on the person's computer, it's not going to change a whole lot. So if you think about computers, some are going to be really slow, some are going to be really fast. We want to normalize it so that the game speed performance is roughly the same regardless of the number of frames per second. And we're going to do that by scaling the movement speed by time.deltatime, which allows us to look at the change in time since the last time we reached out to that method, and we'll be able to figure out how many time slices are there in a frame and scale our speed based on that. Okay, so to fix that, we're going to go into our script. Let's go back into our foo script here. And here is basically what we already have. We want to, let's say we just want to give a constant movement rate. So we'll say move speed is equal to 2.0 float. So now, before, if we would have run this and we would have replaced these with move speed, we'd be moving a tremendous rate because we would have an interaction that would move us every time slice. So what we want to do here, let's go ahead and replace all of our actual movements for this axis, is we want to multiply our move speed by time.deltatime. Now when we do this, basically what's going to happen, because time.deltatime is the amount of time since this update method was called, that is going to be a relatively small number at really, really high frame rates, and a really large number at really low frame rates. So time.deltatime will help to normalize our move speed depending on how fast someone's computer is. So we don't have to worry about really expensive NVIDIA hardware being substantially faster than someone who doesn't have a GPU. They should all be running at roughly the same rate. So let's save this. So we don't have any errors here. Okay. And what we'll do is we'll look at the difference between our W and A, our up and down, which we didn't modify, versus our A and our D, which we did modify. So what you'll notice is the events are still happening at the same rate. We're still getting large numbers of events. It's just that now we are scaling back their impact on the performance of the game, because we're not letting you move a whole lot every single time step. We're basically shrinking that down based off of the amount of time that took place since the last time we called update. If you ever hear of someone talking about frame rate independent gaming or things like that, that's basically what we just did here, is we made this frame rate independent by using time.deltatime. You also use this from time to time in other parts of your game where you want to make sure that the physics system, which uses fix update, and the input system or some other system are all kind of running at roughly the same rate. You use time.deltatime to kind of scale everything down. So now that we've got that piece done, let's stop this. Let's go back into our script. Let's replace all of these with move speed multiplied by time.deltatime. And you can even factor out the time.deltatime up here as well. Probably something you would do if you were optimizing. But now that we've done this, and actually something else that we can do is we can make move speed a public float in our script, so that now we can also specify that from our script. Good habit to have. So as you're playing around with things, someone may want to modify what that move speed looks like. Now you can do that without having to go back into the code and recompile everything. Let's make sure everything builds first. Cool. Now we can go to our cube and we see our move speed is 2. We can make that bigger. We noticed that it was kind of slow last time, so let's make that bigger. 7.45. Cool. And press play. And now everything seems to be working fine. And if we were to change our move speed, which we can while the game is running, we can make that smaller. You can see that you're moving slower in all of your axes. And so that's input. That also gathers the information from a variable that is external to the script, so that now you can kind of turn this into a moving tool, movement controller for keyboard and mouse. And now you have managed to deal with the two core concepts of scripting within Unity. The first being able to manipulate objects by referencing them in public variables so that you can talk to other objects. We've also done some things where we are grabbing things based on the script value. So here we have a find, because if we wanted this game object to not be public, it's public here. But if we wanted it to not be public, we could just do a game object find Waldo, and we wouldn't be exposing that to the outside world where people could try and change it. We've also looked at the input axes, vertical and horizontal, and how we can use that to turn it into a movement system, as well as how we can get to those buttons. All of that, of course, being in the build settings, player settings, going into the input manager, and being able to see where all of that is configured. So that's the basics of scripting. If you get stuck on anything, really the best guide is to go to the Unity documentation, type in what you're looking for. There's scripts for all sorts of things. You will have some scripts in your sample code that are going to be useful things, a much better motion controller than the one that you have here. But that at a high level is scripting. The next thing that we're going to talk about, we will do in a separate video because this one's getting a bit long, is event systems and messaging. How do we get objects to communicate with each other by passing events to each other, as opposed to directly having to access them by passing them to each other. This is also very important because when you're doing things with your game, you're going to want to send events into the world so that your objects don't have to know about each other. If you want to just have something that says, notify me, or just I will listen for events that speak to the player entering this room. When a player enters a room, an event could go out, and then you would hear that event in the messaging system and then act accordingly as a game object. So that's what we're going to go into next. So stay tuned.